But what if we zoom out, way out, and look at the universe itself? What you'll find is something just as strange. That even space, the very backdrop we assume things move through, might not be what we think. Because over the last few decades, physicists studying black holes, gravity, and string theory stumbled onto something they weren't expecting. A realization that shook the foundations of everything. That the universe might not be three-dimensional after all. Or even four. That everything we see, every galaxy, star, and atom could actually be encoded on a distant, lower-dimensional surface. Like a hologram. This isn't metaphor, it's what the math says. And it's now called the holographic principle. Let's go back to where this idea started. Black holes. In the 1970s, physicists like Stephen Hawking and Jacob Bekenstein were wrestling with a paradox. According to quantum mechanics, information can't be destroyed. But according to general relativity, if you throw something into a black hole, it's gone, erased, forever. That created a problem. Because if black holes really destroy information, then quantum mechanics, the most successful theory in physics, breaks. To fix this, Bekenstein made a wild suggestion. He proposed that a black hole's entropy, the measure of its internal information, isn't proportional to its volume like you'd expect. It's proportional to its surface area. Specifically, the area of its event horizon. The invisible boundary beyond which nothing can escape. This was strange. It meant that everything happening inside the black hole was somehow described by information stored on its surface. That's like saying your entire life story, your memories, your body, your thoughts, could be written on your skin, not inside your brain. Like a 3D movie flawlessly described by a 2D script, reality itself seemed to be a projection, not of what lies within, but of what lies on the edge. But here's where things took a leap. In the late 1990s, physicist Juan Maldacena found something remarkable while studying string theory. He showed that a certain kind of universe, one with gravity, could be exactly equivalent to a different kind of theory that had no gravity, defined on the boundary of that universe. This is now known as the AD-SCFT correspondence. And what it told us was profound, that a universe with volume, space, and gravity can be fully described by information living on its boundary, a lower dimensional edge with no gravity, no space, just raw data. From that data, everything else emerges. In other words, the universe we experience, the one that feels big and spacious, might be a projection of something deeper, something flatter, something entirely made of information. And this doesn't just apply to weird string theory models. Physicists began to suspect that this holographic idea might apply everywhere, even here, even now. Which raises a bizarre possibility. Maybe the three-dimensional world you're moving through isn't really 3D. Maybe it's like the hologram on your credit card, a two-dimensional pattern that tricks your brain into seeing depth. So what's real then? The pattern, or the projection? If this is true, then everything you see, feel, and interact with is just an emergent display, a reconstruction from information stored on a cosmic boundary we can't even see. You're not inside the universe.